Hello guys, so in this video I'll show you a one-liner C code, how you can convert it, right, to an object file. We'll inspect the object file and then we will compile or run the executable. So let's say we have something like this, int. So just bear with me here. Kind of remote into this Raspberry. Main seems to be taking a while before I can actually get my screen to toggle, but once I get past this point we should be okay. Yeah, it's taking a while here, guys. So int main, come on. Okay, so now, okay, two more of this and then we get past this point here. So return, let's say I'm returning 42 and I'm gonna send this right to test.c. Good, we got past that point. Now we have the code and now we're gonna do some stuff with this code. So we're gonna take a peek into this code, right? So if we do gcc -c test, wow, it is a challenge to run like this, but I'm doing it in interest that it can show up on the screen better. Yeah, gcc -c test, come on, test.c -o, right, test.o. So now we're compiling this to an object file. All right, so we did that here. Now when we have this object file here, we can inspect this object file, and to inspect the object file we use read elf, right, dash capital S, keep that in mind, test.o. Boom. So when you inspect object file, you have a couple things you're gonna see. You're gonna see sections here. In this case I'm doing dash capital S. So you're having different sections. So you have section for text, for data, for like sim top. Now for text, it's gonna be dealing with like your code, data gonna deal with variables, and sim top gonna deal with your symbols. Now each of these types would have, each of these sections would have types. One of the common types that you can see here is prog bits. Now this reads real stuff that gets loaded, right? So first thing, you have an object file, you inspect it here with capital S, you can see different sections of the file, right? So this is like the big map, like what is the different sections. Good. So we're gonna go now and we're gonna look into the symbol table. The symbol table is like your inventory. Like here is like the big rooms, what is contained in different parts of the file, and now we are going into the nitty-gritties, like the detail. So let's say we use test. So if I use test, sorry, read elf, right? Common S now, right? Test dot o. So here we are. This is in the symbol table, right? So in the symbol table, you see like names. You have main, you have the $A, right? These are a list of things in our code, okay? Um, so main is like the global function, and there are other locals, right? So these symbols, these are symbols, right? Um, they help the linker to stitch everything together, right? Because you have different sections here. So um, now this file can further be like disassembled, right? So you can get more details on the file. Let's say I do object dump, uh, obj, come on, um, dump, right, dash d. So it is a challenge to work on a remote system like this. Dash d test. I have to wait, my friends. So it's just that you're looking at some stuff. So yeah, you can see test.o. I should have mentioned about flags. You can see key to flags here, right? So before I, okay, let's run this object dump and see what happens. So here you get into the assembly code, the machine code here, right? You can see all the details. But going up back here, you see when we have the sections, right? You see there are flags. And you see when we run the code, when we run the read elf here on the object file, they're telling you, right? So for example, you see a flag AX, so we can decode allocate and X, right? Allocate executable. So the object file has sections, big sections. And then you have the symbols. These are like the details, nitty gritty, and each section have types, and that will give you an indication if they are going to be real code that you're going to load. All right, the symbols, these are the different parts that comes together, that are being stitched together to form your file, right? They're going to be linked together. And this is further down in your machine code. So let's link this object file now. So we're gonna do gcc. Come on, buddy, you gotta run. G I need to wait here. I'm sorry about this, but yeah, gcc. So test dot o, right, dash o, right? So we are now going to link the object file into a binary, an executable. right? So when I run gcc test.o, that's my object file. So let's call it final. My binary is going to be called final. So dash o, my output binary is going to be called final. Come on, come on. Come on. Oh, it's not Friday night. Okay, good. We run that, and now we have this binary, and we execute this binary now. All right. I am pausing, waiting here patiently. So it is a challenge to run a code like this, but I guess, yeah. So now we're gonna hit enter. All right, we did that, and now we need to see what was the output. So there's a special shell command or script, echo, right? $, question mark. Now, ideally, this would return a 0, but if you're returning anything else should be a failure, but I'm returning a custom type, which is a number 42. So I want to see if final returns anything. And there you go. That's a 42. So remember, we started here, right? Our code is saying int main return 42, right? Test.c. We compile it to an object file. We inspect the object file. The object file has section headers, different sections. You can think of it like a big warehouse, and you have different zones in it, right? And then you can think of the symbols like the inventory, like your details that is contained in the different sections. And then the linker is like you're stitching it up together, like you're making a product or something. You're just getting all these inventory, putting it together, right? Disassembly, the object dump is like you can get into the nitty-gritties of stuff here, right? And then when we link everything up, we create a binary, and then we can run it, and we get the final output. Let's say your product has a function. It will give out some output, and that output here in this case is 42. All right, guys. So this video give you an overview how we can take a code and decode that code to see what is in it, and then show how you arrive at the output, right? So I will stop this video here, and thanks for your patience in staying, if you did stay to the end, to see this code through. Okay, bye for now.